number 2, this function fxy in the form of the natural log of the quantity x squared plus 4y. And we are going to find the second partial derivative at x equals 2 and y equals 1/2. We're going to find fx first, which is the first partial derivative, or the partial with respect to x of the natural log of x squared plus 4y. You have composite function. Yes, you're going to use the chain rule. The outside layer, the inside layer. Okay, that's the outside, that's the inside, or the layer 1, layer 2. So the partial derivative with respect to log is 1 over whatever the quantity is, and then multiply by the partial derivative with respect to x of the inner portion or the inner expression. Okay, so this is from the layer 1 and this is from the layer 2 derivative. And the layer 2 is the one that involving the partial derivative. You see x, you're going to treat it as the variable. You see y is going to be the constant. So the second term is the standalone constant. So it will become 1 over x squared plus 4y for the first group, and then multiply by 2x plus 0. Or we can rewrite it as the fx is 2x on the top divided by the quantity x squared plus 4y. Okay, so we get the first partial derivative. Our goal is the second partial derivative. Next one, fxx, which is the partial derivative with respect to x of 2x on the top, x squared plus 4y on the bottom. Guess what? We have the quotient. What rule we're gonna use?
Rule.
Quotient rule. The high over the low. Fun, huh?
Not for me.
Gonna be the low d high minus high d low. Draw the line, low squared. Okay. And the low is, just follow, the low is the quantity x squared plus 4y. D high means the partial derivative with respect to x. We target the x term, right? We're gonna keep an eye on the partial with respect to x of the high term. The high term is 2x, and then minus the high 2x times the partial with respect to x of the low term, and all divided by the lower square, which is x squared plus 4y all squared. Now we're gonna work on each partial derivative. This part gonna give you what? 2, because you see x here, right? Just treat it normally. For the second part, you see x here, you see x here, but the 4y gonna be treated as a constant. So this term gonna be 2x as well. I mean 2x, not as well, just the 2x. And then put them together. That means the fxx, the numerator becomes the quantity x squared plus 4y times 2 minus 2x times 2x, so that is 4x squared, all divided by the quantity x squared plus 4y squared. And then we're going to simplify by distributing 2 inside of the first group there, becomes 2x squared plus 8y minus 4x squared, all divided by x squared plus 4y to the power 2. 2x squared, 4x squared reduced to be 8y minus 2x squared, all over the quantity x squared plus 4y to the power second. So this is the second partial derivative for any xy. And the problem asks you to evaluate when x is 2, y is 1/2. X is 2, y is 1/2. So then the fx x for 2 1/2 equals 8 multiplied by 1/2. Replace y with the 1/2. And then minus 2 times 2 squared. All divided by quantity. X is 2 squared plus 4 times 1/2 quantity squared. It's the layer of the numbers. So 8 and 2, that's 4. This one 2 times 4, that's 8. And then this is 4. And this one is 2. Let's clean up real quick. 4 minus 8 on the top divided by the quantity 4 plus 2 squared on the bottom, or negative 4 over 6 squared, which is negative 4 over 36. And that number simplified to be negative 1 over 9 as the fxx at 2 1/2.